We're going to answer this question before us. It says, a bag contains 5 blue counters and 3 red counters. 2 counters are removed without replacement. Draw a tree diagram and find the probability that the counters are the same color and at least one counter is blue. So we have a bag, it has 5 blue and 3 red counters, and we're removing 2 counters. So I'm going to pull a blue one or red one out on my first pull, and then a blue one or red one out, a blue one or red one out on my second pull. So first pull, second pull. Now we also need to think about the probability of getting either a blue or red one here. And this is where we have something extremely important. Do you see how it says without replacement? That's going to really affect the probabilities going on here. But let's first begin with the easy one. What's the probability of pulling either a blue or red one out? Well, I know that there are 5 blue and 3 red. So that means there are 8 in total. The probability of pulling a blue one out will be 5. The probability of pulling a red one out will be 3. Now, let's look over here now. I've pulled a blue one out. I have 1 less in total for both the blue and the red. That makes sense. If I've pulled a blue one out, I have 1 less blue. So now I have 4 left, so it's 4 out of 7 if I pull another blue one out. And now in terms of pulling a red one out, there are 3 still in there because I haven't pulled one out. And we can double check that this is correct because 4 on 7 plus 3 on 7 is 7 on 7, which is 1. So that checks out there. We come over here, so I've pulled a red one out. So that means I have 7 to pull from in each option here. I haven't pulled a blue one out yet, so there's still 5 there, and I have pulled a red one out, so now there's 2 there. So 5 on 7, 2 on 7, 7 on 7, 1 in total. That all checks out. Then the next thing I'm going to do is I'm going to list my sample space. Sample space. Blue, 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 red, red, blue, red, red. Okay, now the first one. Let me actually just fix up the colors here a little bit. Okay, the first one here is saying the counters are the same color. So what's the probability that the counters are the same color? So that's either the blue blue or the red red. The blue blue or the red red. Remember, to find the probability, you multiply across the branches. So I'm going to go 5 on 8 times 4 on 7. I'm using my calculator here, that's 5 on 14. And then down here, this will be 3 on 8 times 2 on 7, which is 3 on 28. So for A here, what I'm going to do is go 5 on 14 plus 3 on 28, which is going to be 13 on 28. Perfect. That is the answer to the first one, 13 on 28. Let's now figure out the answer to the next one here. So this is saying at least 1 counter is blue. So at least 1 counter is blue. So that would include this one, it would include this one, and it would include this one. It wouldn't include this. Now there's 2 ways of actually going about this question. The first way is just, as you would expect, figuring out the probabilities of these and then adding it with that. So let's just do that. So we can go 5 on 8 times 3 on 7 is equal to 15 on 56. And this will be 3 on 8 times 5 on 7, which is going to be 15 on 56 as well. So now I'm entering B here. And what I could do is I could just add up these, because all of these have at least 1 blue. So 5 on 14 plus 15 on 56 plus 15 on 56. And when I add all of these together, let me see, maybe I can do it on one line. When I add all of these together, what I'm going to get out as my answer is 25 on 28. 25, that's not a 25. 25 on 28. Perfect. Now, is there a better way to do this? And there absolutely is. There is a better way to do this, which would save you some time. So let's write or. What you could do is say, well, at least 1 is blue. At least 1 is blue. As you can see here, there was only 1 option that was excluded. So if I went 1, because that's the total possibility of everything, right? So if you add all your probabilities together, so if I added all of these together, I know that it's going to be equal to 1. So if I went 1 minus this one down here, 3 on 28, and see what that was equal to, well, that's going to be equal to 25 on 28, because you see what we wanted was just the sum of all of these probabilities. So the reason why this is so much quicker, and as you can see, you get the same answer, is instead of multiplying across these branches 3 times and getting all of these, then adding all of them up, you could have just done it for 1 and then gone 1 minus this right here. And then just like that, you've got your answer. So that's why that's a quicker way to do it. But at the end of the way, you just need to know how to do both of them and feel comfortable with doing both of them.